Welcome to physics. This is our third activity with our motion unit. And again, we're still focusing on scenarios of motion that are related to constant velocity or where the velocity doesn't change. And again, another way of saying that is your speed stays the same. So again, picture you're in a car, you're going 20 miles per hour through a school zone. Okay, that's a normal speed limit for a school zone. And so that entire time you're going 20 miles per hour. That is your constant velocity. And then we can use that to calculate things like distance if we know how long you were driving at 20 miles per hour. We can also look at things like, how long did it take you? Okay, you're driving 20 miles per hour for a mile. School zone probably wouldn't be a mile, but let's just say it's a mile. We could calculate how long would it take you. Okay, so that would be the time, and that's what we're doing today. And next time we're going to be solving for velocity. So if we know the distance and we know the time, then we can calculate the velocity that an object was moving. So, but let's focus on time. So solving for time, and again, another scenario would be, grandma lives 30 miles away, and you are on the highway going 55 miles per hour. How long would it take to get to grandma's house, right? So again, we can answer that question by using our linear equation. So uh, going back to what we kind of first started talking about with distance earlier. Again, this with the constant velocity, we can use what's called this linear equation because the relationship between distance and the relationship between time is going to be linear. It's going to create a line in our data. And therefore, we can use this. But this is a very kind of unnecessarily complicated way of looking at it. And then you're trying to remember what the variables mean. So, again, we're rewriting it with these variables in mind. And we're going to keep in mind that we're solving for time now. Okay, we started right here. You can see solving for distance. That's what we did. Distance equals velocity times time plus your starting distance. Now though, I've gone ahead and I've rearranged it for you. And basically I've gotten t by itself. So now we're solving for time. So time equals distance minus starting distance. And again, if you don't have a starting distance, it'll just be distance divided by velocity. So in this scenario, there's no starting distance. We have our distance of 50 meters divided by our velocity, and that gives us a time of 25 seconds. So, I'm going to keep saying this, so hopefully we'll start to remember your. Whoops, I clicked. Your units for your velocity are the most important thing. So if your units for velocity is meters per second, then your distance also needs to be in meters. And in this case, it is. Then when we're trying to answer time, okay, if you go 2 meters per second for 50 meters, uh, it's not going to take you 25 hours. It's not going to take you 25 days. It's going to take you 25 seconds. And we know that that's because of the velocity there. So uh, do our best to keep that in mind as we're trying to remember which units to use. Next, we have word problems again. Important part of this is, can you pull out the important information? So at a Frisbee golf competition in 2007, Jack Roddick made a world distance record at the 85 and older category by throwing his Frisbee 54 meters. So hopefully we see, okay, there's a distance. If the Frisbee was thrown horizontally with a speed of 13.5 meters per second, there's a velocity. How long did the disc remain in the air? So that it's asking for how much time. So we plug in those numbers. We have our distance of 54 meters divided by 13.5 meters per second, and that will get you 4 seconds. So then now you're going to practice. So some things to keep in mind. This is 0.5, not 5. That'll change your answer. Make sure your units match meters per second, meters. Your answer then would be in seconds. Starting distance. Ooh, and there's a typo, so make sure that that is 5 meters. That's what that's supposed to be. Kilometers per hour. So now your answer will be in hours, and your kilometers match. So that's good. And here's a tricky one. Okay, our answer will be in seconds, but this is kilometers and this is meters. So we have to figure out how can we convert our kilometers to meters. And if we remember from our first week, 1 kilometer is 1,000 meters. Excuse me. So 20 times 1,000 will help you get that answer. And then you want to do the same for your starting distance. Then we have 2 word problems. So first word problem, okay, really it's pretty standard as you get a distance for 100 kilometers, and you get 5.7 kilometers per year. So keep in mind your unit of time is a year. So your answer should be in years. And last but not least, this one is asking you to do really a 2-step problem. You're looking at how long would it take you to travel 133 miles if you're going 55 miles per hour, and then compare that to 65 miles per hour. So if you're able to do the same trip, one person goes 55, the other person goes 65, how much time would you save? So you have to answer both of those, and then you have to figure out the difference in time. How much shorter amount of time would it take? And that's it. So then obviously, if you have questions, please let me know. And you can email me or ask me in class. And good luck. Thank you for being here. End. Oh, it moved.